Hi there. Well, in this section 4.4, what I'm going to do is I'm going to go through some of the assignment. I ran off the assignment. Your numbers will be a little bit different than mine, but they'll basically be the same, just a little bit different numbers. They're not going to change the whole problem for you. But let's go ahead and number one, we've already done. We did that in section 4.3. So I'm going to look at number two here, and we're going to set them up. We may not solve them all, but sometimes it's getting them set up and then just kind of walk through how you could solve it, but mainly just getting these set up and translating them from English into a math equation so that you're able to solve it. And story problems give people some issues at times, so let's see if we can help you out. All right, so let's look at number two. Each course at College X is worth either 4 or 5 credits. The members of the men's swim team are taking a total of 46 courses that are worth a total of 195 credits. How many 4-credit courses and how many 5-credit courses are being taken? Well, what we're going to do is we're going to go let X equal the number of 4-credit courses. The number of 4-credit courses, and Y is going to equal the number of 5-credit courses. So let's read our first sentence. Each course at College X is worth, okay, there's not much in this sentence other than setting this up. The members of the men's swim team are taking a total of 46 courses. So right there, we know that if we take X plus Y, we're going to get 46. So there's one of our equations from that statement right there. You're going to see a pattern in that a lot of these will give you a number, a number of coins, a number of courses, a number of pounds. And then they're going to talk about more of a percent or a total charge, something like that in the next equation. But you will start to see this pattern. Now, that are worth a total of 195 credits. So that's where our second sentence is going to come from, is the second part of that sentence. So rather than making them 2 sentences like we did in 4.3, we had to decipher and break this one sentence down into 2 parts. So we have a total amount, X plus Y is 46, and then the total credits are 195. So if I take 4 times the number of 4-credit courses plus 5 times the number of 5-credit courses, each course is 4 credits, each of these is 5, I'm going to come up with 195 credits total. So those are the 2 equations you would solve. Now we're not going to finish this. We did that in 4.2 and 4.3, but as an idea, I would, if you wanted to eliminate the X's, I'd multiply everything by a -4. You're going to see that a lot of times in these story problems that they're set up for the elimination method rather than substitution. As I'm not saying you could get the X by itself and then put it right here. You could get the Y by itself and then put whatever it's equal to right here and solve it. Or you could eliminate the X's, you could multiply this by a -5 and eliminate the Y's and finish that up. All right, so that sets up number 2. Let's look at number 3. All right, as a part of a fundraiser, a local organization collected, let me see, I'm going to move it up. I'm going to move this up just a little bit, just so we don't have that other one in our way. There we go. All right. As part of a fundraiser, a local organization collected 439 returnable bottles and cans, some worth 5 cents each and the rest worth 10 cents each. If the total value of the cans and bottles was $27.25, how many 5-cent bottles or cans and how many 10-cent bottles or cans? So looking at this right here, okay, I'm going to go ahead and make the X in our equation that we're going to write equal to the number of 5-cent bottles or cans. And I'll let the Y equal this one right here. Y is going to equal the number of 10-cent bottles or cans. All right, let's go ahead and see what we can do as far as two equations, because we have two unknowns, so we'll need two equations. As part of a fundraiser, a local organization collected 439 returnable bottles and cans. What that means is that they gave us a total. I'm just going to write it over here. I know that if I add the number of 5-cent bottles or cans and I add the number of 10-cent bottles and cans, how many there are, I am going to come up with 439. So you have an amount. It could be the amount of seats in a theater. In this case, it's the number of 5-cent bottles and cans plus the number of 10-cent bottles and cans. In the one before, it was the number of classes. Generally, we have this one right here. Not always, but generally. Now let's look for another one. Let's see. If the total value of the cans and bottles was $27.25. So we've got a value equation. Sometimes I call it I probably shouldn't call it an amount equation because it kind of goes with this right here, but it has to do with the amount of money. But we'll call it a value. We'll stay consistent with what they have here. What that means is if I have so many of these 5-cent bottles, and if I cash them in, each one is worth 5 cents. Now you're thinking, why did I change it to 0.05? Well, this represents 5 cents only in dollars. Why am I doing dollars? Because this one is in dollars. It's very important that you keep your units consistent. Another way, well, here, we'll go ahead and we'll finish this one. All right, I moved the decimal over twice to change it into dollars so it matched this one. And then we'll look at it a different way that you might like better. 10 cents. So each of these is worth 10 cents. $0.10. And I'm going to get a total amount of $27.25. So everything is in dollars. Now, what if you wanted to stay with the 5 and the 10? If you wanted to have stayed with the 5 and the 10, I'll put it over here. We would have gone 5x, how many cents times the number at that price, plus 10 times y. But rather than putting $27.25, I'm going to change that to pennies by moving the decimal over twice. 2,725 cents. 5 cents, 10 cents. This one had to be put into cents. So you do have to stay consistent. Pick one. This I like better because what I would do, and I'm going to put this one over it. I don't like to work with decimals or fractions. So to begin with, I would have multiplied this by 100. That moves the decimal over twice on each one. anyways. So that way I don't have to work with these decimals. The main thing is to stay consistent, and that you can eliminate decimals in the same way you can eliminate a fraction. So I just multiply by 100 because I want to move it over twice. And that would get rid of each of those decimals. So 2 zeros, multiply it by 100, and it would move these over and make it look like this. Once I have this, you could multiply this top equation by a -5, and then your x's will drop out, and then you can solve it for y. Or you can multiply the top equation by a -10, and then the y's would drop out, and you could solve it for x and then put it in here and find the y. All right, so again, we're mainly just setting these up. That seems to give people most of the trouble. So this is for number 3, would be the best. I just, just make sure you stay consistent here. I do like just to go to pennies straight. I do like just writing it 5 cents, 10 cents. And just remember that, to change dollars to cents, you move it to the right twice. And that'll change that dollars into cents. All right, to set that one up, let's look at another one. Let's look at number 4 and see what we think. Okay, there were 276 tickets purchased for a Major League Baseball game. The lower reserve tickets cost $9.50, and the upper reserve tickets cost $8. The total amount of money spent was $2,362.50. How much of each kind of ticket were purchased? So they want to know how many lower reserved. We're going to make that X. Maybe I can just write it right here. How many upper reserve tickets were purchased? We'll call those Y. Now we know we have a total amount. So this is the number of lower. This is how many upper. And I know that I have a total of 276. So I will take X plus Y equals 276. All right, you have a number one, how many? And then I have a value equation, which is pretty common in a lot of these. Now the value equation, I have so many of the lower, and each one is 950. So to find the total value of the lower, I would take 950 times the number of tickets that I have, plus the upper reserve tickets were $8 a piece. So $8 times Y. Notice I'm in dollars. The 950 is dollars, the 8 is in dollars, and the total amount is in dollars. 0.50. Okay. So there's our two equations. And okay, the thing is, you could solve it from here, and I would solve it from here. I don't think I would necessarily, but you can move the decimal over twice on each of the second equation. 950, 800, 23,000. Oh, what would that be? That would be 236,250. But you have a calculator. And what you could do, knowing that you have a calculator, is you could just multiply this top equation by a -8, and then the y's will drop out. Don't forget to take the -8 times this. You're going to be dealing with a decimal on your calculator, but it's not that bad. All righty. And again, if you don't end up with a whole number here, because you really can't buy half a ticket, you might want to go back and see, did I transpose a number? That happens, I do it. Did I copy the problem down right? Things like that. So you should end up with a whole number of tickets in both cases. But here, I really wouldn't worry about the decimals. I just go ahead and multiply that top equation by a -8. And then when you add them together, the y's will drop out. All right, so see if you can go from there. And if you're having some problems going from here, let me know, and you and I can work together on Zoom. All right, let's look at another one. Now this one, no, I can give the percent one. You have to be careful on this one. There is a trick on one of these equations. The coffee counter charges $8 per pound for Kenyan French roast coffee and $12 per pound for Sumatran coffee. How much of each type should be used to make a 22-pound blend that sells for $10 per pound? All right, so we've got how many pounds rather than how many seats or how many classes for credit or how many bottles or cans. For us, it's how many pounds. So I think what we'll do is we'll have, I could use a K and an S, but I'm just going to go ahead and stick K. The X is going to be the Kenya roast, how many pounds of Kenya roast. And the Y is going to represent how many pounds of Sumatran coffee we're going to have. I do know that when I take the Kenyan, how many pounds of the Kenyan plus how many pounds of the Sumatran, I'm going to have a total of 22 pounds. So X plus Y equals 22 pounds. Now, we have a value equation. Just like we had a value equation with the baseball seats. So what we do is each one of these pounds costs $8. So $8 times the number of pounds of the Kenyan. Plus, I have 12 pounds of Sumatran coffee. So I'm going to go 12 times the number of pounds. This is $8 per pound times the number of pounds will tell me how much in dollars I have here. $12 per pound times the number of pounds will tell me how much total the Sumatran coffee is. Now here's the key. It does not equal 10. It does not, just to $10. This is $10 per pound. It's not a total of $10, it's $10 per pound. So to find the total number, you would take 10 times the number of pounds, which is 22. That's the trick on this one. How much per pound times the number of pounds. How much per pound times the number of pounds. How much equals how much per pound times the number of pounds. Once you've done that, then it's very similar to the others. So I'll go ahead and write our first equation. And then we have 8x. I'm trying to line them up, but oh well. Times 220. So that, it's $220. You've got 22 pounds and you're going to sell it for $10 a pound. So here we have our two equations. You could multiply this top equation, each term, by a -8. So that when you add these together, -8x plus, I'm just bringing it down here when I multiply, -8y equals, what is that, 176? I'm going to double check. Times 8. Yep. -176. And now when you add these together, the x's drop out. And then once you find the y, you put it back into there. I went a little bit further on that one. But I really wanted you to see that this is the tricky part right here. That's the tricky part. All righty. Let's look at number 6. I normally do not do the charts, but but some people like the charts. So on this one, we're going to look at a chart. And then I also, if you would like, if you like charts and that was the way you were trained, that's fine, or in your earlier math classes, I have these word problem frames that I put in the module, and you can always copy these off, and it would give you a template to follow for those of you that like the charts. And we may do one of them here with this distance one. We may use this one here. Okay. But this is very similar to the one we did with the coffee just now. An experiment requires mixing 70% acid solution with a 40% acid solution to create 250 milliliters of a 58% acid solution. So you're just working on percentages rather than how much per pound the coffee was. It's exactly the same. How much 40% acid solution should be used? So we have and how much 70% acid solution. Complete the table to the right. So how much 70% acid and how much 40% acid. They make the 70% acid the X and the 40% acid the Y. Now here is the chart that you're going to be asked to fill out in these blue sections here. What we normally do is, like I say, we have a number, we have a number amount, and let's see, how many total are we going to have? 250 milliliters. So looking at the way we've done the other ones, our amount equation, so much of the 70% plus so much of the 40% equals a total amount, which would be 250. Okay. But you have to fill in the chart. So here, well, no, I think we'll go ahead and we'll solve it like we've been doing the others, and then we'll come back and look at the chart. So there we have amount. Now we have a value. We have a percentage of the X, which is a 70% X. And when we're doing mathematics, we usually move the decimal over twice in order to work with it. In order to multiply it, not so much add, but multiply and divide. All right, and then we have a 40%. That's how many milliliters of the 40%. To get, we have a percent of our solution. We want it to be a 58%. And we will have 250 milliliters. So you can see the similarity with the coffee. Percent times how much we have, plus the percent times how many we have of that, equals the percent of the result times how many we have. So again, this is one you could work with. I would move the decimal to the right twice on each of these. I'd multiply by 100 to get rid of the decimals, but you don't necessarily have to. It might be a little bit easier. So to solve that, to finish that up. But filling in the chart, the amount of solution, we have X and Y, and the total amount the amount of solution we're going to have at the end is 250. So you would use this to come up with an equation. Okay. Then we have a 70% solution, and we're going to have a 40% solution here, and a 58. And then we multiply. So here they have the 0.4. You could just write 0.7 or 0.70. Okay, it doesn't matter. Pearson will count either 0.7 or 0.70 correct. So we multiply these to get here. We multiply here to get here. They already did that, the 0.4. And then we multiply these two together to get to the total. Well, let's go ahead and find out what that is. let's do that. 0.58 times 250, 145. Let's see, I'd better make sure that I know what Pearson wants for this. Let's see. And let's see, this is number 6. Yeah, they want the 145. I wanted to make sure they didn't want you to write 0.58 times this. They actually want the 145. Okay. So you have x plus y equals 250. And then here, 0.7x plus 0.4y equals 145. Oh, for some reason, okay, good. My screen went crazy. So you can use these two to solve your equation. You have x plus y, same as we did, our amount. And then here we have 0.7x plus 0.4y equals 145. I guess the nice thing about the second part is that here you'd only have to multiply by 10, and move it over once. So maybe it's a good idea to multiply that out so that you really don't have to move things over twice. You can just move it over once. Move it over once, and then move this over once to get this equation and this equation. Let me finish. Okay, 7x plus, I'm moving everything, I'm multiplying by 10 to get rid of my decimals. So the two equations you're going to work with, I'm going to get a piece of paper. I did have some blanks. Yeah, I guess I can use the back of this one. I want you to be able to solve this easily. X plus Y, our amount that we have, milliliters, our percentages, once we've simplified it. And then so you can multiply this one, you can multiply by a -4 everything. And when you add them together, the Y's drop out. And then you can put it back in and solve it for X. Knowing that X is the 70% and the Y represents how much of the 40%. All righty. I hope that helped. We'll see. Let's see. I didn't want to do that one. I don't think we'll do that one. I want to look at, here we have a soybean one. So let's look at number 7. It's a good idea to try to set these up, and if you can, then watch this. Same as the one with the acid that we just did. We have soybean meal is 18% protein. Cornmeal is 9% protein. How many pounds should each be mixed together in order to get 360-pound mixture that is 16% protein? It's important that we have protein, 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 which is good. So they're not trying to trick you. How many pounds of how many pounds of the cornmeal should be in the mixture? We're going to call the cornmeal X, and we're going to call this how many pounds of soybeans the Y. Y represents the number of pounds of the soybeans. Again, we have a total amount as far as the pounds go, and it looks like we have 360 pounds. Let's do that one. X plus Y equals 360 pounds. Now we're going to look at our value or our percent equation. So we've got 18% times the number of pounds of cornmeal. Ooh, nope, Sorry, cornmeal's 9. 0.09 is our cornmeal. Glad I caught that. Soybean is our what? Soybean is 18%, 0.18. We want our result to be 16% times the total, 0.16 times 360. All righty. So then we multiply that out and then see what we want to do as far as getting rid of the decimals. Let's go ahead and take 0.16 times 360, 57.6. So we've got 0.09x plus 0.18y equals 57.6. I'll move it over. I'm going to go ahead and move the decimal over twice. I'm going to multiply everything by 100. So we end up with 9x plus 18y, 5760. And our first equation from the way up there. And now you can eliminate the x's, multiply. Here's our two equations, multiply this one by maybe a -9. So that, and again, make sure you take the -9 times the 360. And then when you add them together, the x's drop out, and then you can find the y and then substitute it in and find the x. All righty, awesome. Let's look at another one. Oh, here we go, trains. I don't know if this is the last one we're going to do. You might, a basketball player. I'll look at the other ones and see if I think you might have some issues with it, but I think they're pretty much the same as the others. All right, a train leaves a station and travels north at a speed of 45 miles per hour. 4 hours later, a second train leaves on a parallel track and travels north at 105 miles per hour. How far from the station will they meet? Pictures are awesome. And then I'm also going to use the chart that you could, that PDF chart, if you do like that. And I know that some of the 1400 teachers will use the chart. And I want you to kind of be a little familiar with it. But here, we've got this, we have a train and it's going north at 45 miles per hour. Let's kind of get a picture of what's going on. 4 hours later, a second train leaves on a parallel track, but it's going a lot faster. But it's going to leave later. So this one's going 105 miles per hour. Now, what do you do about the time? Because what we're going to be doing is we're going to be filling in distance equals rate. I guess I can use a capital R. The only reason I want to use capital R, I want to use a capital T so it doesn't look like a plus sign. We're going to be looking at distance equals rate times time. Well, the time is kind of where we're at right now. We've got the rate of these two trains. They're both headed north. This one, the one that first left, we're going to call it, how long will it be traveling? Well, we're not sure. Because we want to know, well, we have to figure out the time and then we could figure out how far they went. And this one left 4 hours later. So the time for this one is T minus 4. When will they meet? I know that when they meet, the distances that they have traveled are the same. So the distance here will be equal to the distance here. Well, we do know that distance equals rate times time. So this distance is the rate of our first train times the time it's traveling. We don't know. We're going to call it T. The distance for this one I guess I can just use this formula. Well, no, that's all right. The distance for this one is the rate of this one, which is 105, the second train, and the time is t minus 4. So distance equals rate times time. Distance equals rate times time. So I do know that these two distances are equal to each other. So 45t is equal to, when they meet, their distances will be equal. So this is a substitution. So it's almost as if I'm taking this and putting it in right here. So their distances, the distance of this one, of the first train, is equal to the distance of the second train. It's a substitution idea, D1 and D2. And I do know that those are equal to each other. So I set those equal to each other. I substitute this in right here or this in right here, however you want to think of that. And now you solve it for the time. And once you have the time, let's see, 420. I kind of did some of the numbers here. Ooh, 115. Did I copy it down right? No, I have 105. And the other one, for some reason, I had to fit 115. So I'm going to double check my numbers. $420. That was right. So then you'll subtract 105t. $60t. Oh, negative 60t. So it looks like t is equal to a positive 7. When you divide by an, oh, I'm sorry, let me make sure you can see that. So what I did is I used the distributive property. Then I'm going to solve it for t. I subtracted 105 from both sides, got 60. And minus 420. Divide by a negative 60, so the time is 7. But that's not what they want. They don't want the time. They want to know the miles. So you can either put this in right here, 45 times 7, or you can put it in right here, 7 minus 4, which is 3 times this. You'll get the same answer. And your numbers are different. 315 miles. Oh, again, let's move it down a little bit. But this is what they wanted, but you use the time to find it. All right, I am going to fill in the chart. Just, some of you may be used to the chart. And so we'll use the chart, these word problem frames. This is called word problem frames. You can use these with the percents, with money, to come up with your equations. Oh, that's why. Okay. So looking at this, we can, instead of trip 1, we can call it train 1 and train 2. And whenever you're dealing with miles per hour, you'll always be looking at this equation somehow. Now, the distance of train 1, we weren't really sure. So you can call it X or D. We can just call it D. The rate of train 1, let me put up our information again, just so that we have something to follow here. I don't know if you guys can see. Yeah, there we go. Where did I get 50? Oh, this one's 45. Trying to put all of this up so that you can see everything. I have too many of these here. There. All right. This is the one we just did, and we're going to look at the chart method. If you like the other method, it's fine. You don't have to watch this. All right, a train leaves the station and travels north. So again, at a speed, the rate is 45. And the time, we don't know. We'll just call it capital T. Now the second train leaves on a parallel track and travels north at 105, and the distances will be equal. So this one is going to travel, its rate is 105 miles per hour. And let's see, the time is T minus 4. Okay. So then totals, it's mainly, we're just going to go this way. The distance equals the rate times the time. Here, the distance equals the rate times the time. And in this case, the distances are the same. We don't really have a total distance. This one's done differently. Sometimes you'll have two of them, one will go a certain distance and the other one will go another distance for a total. So there are times when you do have the total, but in this case, we're just going to move across, knowing that these distances are the same when they meet. This, set it equal to this. And then you can solve it for the time, but it's just a way of organizing. All righty. Okay, now looking at the other two, I think it will be fine. I think that they're very similar to the other ones that we did. So if you're having issues, I highly recommend that you contact me so we can go through them. Otherwise, that's all for this section. Thank you, and let me know if you need help. Bye-bye.